In our previous video, we were looking at different types of data analytics, from supervised learning, unsupervised learning, reinforced learning, neural networks all fall into different types of data analytics. So when we're doing data analytics, we're using machine learning, we're using artificial intelligence. So why should we use machines to help us make decisions? Well, humans can't process all the information, and humans can suffer from bias.
Before we dive any further, let's look at what we mean by machine learning. So we can divide machine learning into supervised, unsupervised, and reinforced learning. So when we look at supervised learning, we're going to look at classification models like k-nearest neighbors, generalized linear models, support vector machines, naive Bayes, decision trees, random forests, and gradient boosting. There are other classification models, but we're just going to look at a handful of them. Then we can also, with classification models, what you're doing is identifying a group. So you're using these methods to say that fraud or no fraud, they're from this location or that location, this is a hat and that is a shoe. So we're classifying them and we have labels to test how well our model works and we can improve its accuracy. In comparison, supervised learning can be regression. And so instead of identifying a label, we're identifying a value. And so we have linear regression, which can be improved through Ridge and Lasso. And we have polynomial regression. So in these cases here, they're all supervised learning. That is, we know the answers, we have the labels for the classification, we have the values for the regression, and we can tweak the algorithm to improve it. So we test it on a set of data, we train it on a set of data, and then we test to see how well it worked. Under supervised learning, we're also going to look at some different types of networks. We can look at social network analysis in terms of connections that people have and how information moves from person to person. We can also look at SEIR, which is susceptible, exposed, infected, recovered. And so this is what they're using in epidemiology to see how you transmit infectious diseases, for example. So how does measles spread? So networks look at relationships between entities or events. We're also going to create some artificial neural networks. Artificial neural networks attempt to replicate how the brain works. And we have methods like recurrent neural networks and convolution neural networks where we can do things like do even more complicated regression because there are hidden variables. So we use that in finance to predict stocks, or we can use this in a more natural language processing, text analysis, or an image recognition. So it allows for a more complicated model than we would have in, say, classification or regression. On the unsupervised side, we have no labels already, so we are going to have to look for clusters, try to identify groups that have things in common that we could give a label to. But we aren't able to train and test the algorithm because we don't already know the labels ahead of time. We're going to look at k-means clustering, hierarchical or agglomerative clustering, and dbScan. There are other clustering methods, but we'll focus on those couple to help us identify what particular, we'll find groups, we'll find clusters, and so we'll give them labels with cluster analysis. When we do our cluster analysis or our classification, I'm just going to move my face for a moment, we will do some dimension reduction. So when you have very large data sets, you need to reduce the data set down. So we're going to look at principal component analysis, singular value decomposition, manifold learning, and TSNE. These are ways to take a data set where you have lots of variables and create new variables that are really a combination of those existing ones to help reduce the size of your data set to speed up your cluster analysis or classification. Now, if we're talking data analytics, we also have non-AI or machine learning methods. And so we will look at linear programming. We will also look at decision trees here, a different decision tree than the one that's mentioned there, a non-AI version. So here we're looking for optimization, helping us make decisions, but we're not using these machine learning methods to do that. We'll look at Monte Carlo simulations, and we'll look at queuing. Now, one more thing on this here, or two more things, I guess, on our visual here, is that we have, in terms of machine learning, we have supervised learning, unsupervised learning, and we have what is called reinforced learning. And so reinforced learning is where we set a reward structure. So there's an optimization strategy. So this is the machine learning version of those optimizations that we were just talking about in those gray boxes. Here, there is an optimization strategy, and then rewards or punishments, and then the machine is trying to find the best solution. So reinforced learning is when we're trying to find the best way to order steps in a process. We often use it with logistics, trying to figure out how to move things around, but we'll look at reinforced learning as well. So 3 types of machine learning: supervised, reinforced, and unsupervised. And then beyond the scope of these set of videos that we have here is generative AI. You've heard of ChatGPT, for example, or Midjourney that creates images. This is a combination of supervised learning and reinforced learning. So, for example, with ChatGPT, we've scraped the internet. We looked at all this text, and from this text, we've trained ChatGPT on how to put together sentences and ideas. And then you go in and you play with ChatGPT and you tell it when to re-roll it and give you a new response. You give it a thumbs up or a thumbs down. So it's learning whether or not it gave you a satisfactory response, depending on whether you cued it for giving you another response or gave it a thumbs up or a thumbs down. And so it's learning from that, from itself and from its processes. That's the reinforced learning aspect of it. So machine learning, supervised, reinforced, unsupervised, and that, of course, is leading to the generative AI that is that we're seeing widespread. As we look at analytics, we said we also have those non-machine learning methods, and that is this section over here in this data analytics that you see is not part of this artificial intelligence or deep learning. And the neural networks we talked about there, that's this artificial neural network process here where we're trying to find hidden layers and unknown variables.
What we want to talk about here in this video is why we would use those other approaches, those machine learning approaches, where we're using machines to help us make decisions. And we do that because humans can't process all the information and humans suffer from bias. So when we make decisions, we think of ourselves as rational decision makers. That is, we weigh the pros and cons and we make the best choice that we can. But we're actually not rational decision makers because we don't have all of the information, which means our decisions are bounded rational decisions. We are constrained by our human abilities to process information. So what constrains you in your decision making? Well, your awareness. You may not know what else is out there. You might be bound in terms of personal ethics and preferences. We look for shortcuts, right? We don't want to take the time and effort that it might be required to collect all the information. And so we might just make a decision based on the information that we have readily available. We are bounded by our self-interest, right? If we don't gain from it, are you really going to spend the time and effort to do it if it's not going to have a payoff, a reward? And we're bounded by our willpower. So we give a preference to the present and not enough to the future. So when you think about decision making, humans tend to have very short-term priorities. They don't tend to consider the long-term implications of decisions. And so because of that, because we are not truly rational, we have bounded rationality, we are biased. And the solutions we come up with are going to be limited. We don't have enough time and resources to brainstorm all the alternatives. We use satisficing. So satisficing is when you stop looking for an alternative because you've come across one that's good enough. not the optimal solution, but good enough. And so that's going to limit what we're coming up with as solutions. Hubris, our sense of pride, certainty, confidence, all of that is going to impact the recommendations we make, the solutions we come up with. We're also highly influenced by the organizational culture, by the politics, by political considerations, and we have to think about the escalation of commitment or sunk cost error. So when we make decisions, if we've already committed a bunch of time, we tend to just keep going. Even if we know it's a bad idea, we've already put so much time into it, we might as well just keep at it. Or sunk cost, maybe we put a bunch of money into it, and because we feel like, well, we committed all that money, we need to keep at it, even if we realize that it wasn't a good decision and it wasn't a good use of money. So one of the reasons for using machines to make decisions, to identify patterns, to do that predictive and prescriptive analytics is that they don't have this bounded rationality problem. Okay? And so they're not hindered like we are based on complexity of decisions, as long as you have sufficient computing power. Information overload, right? Big data can handle a lot of analysis. We can limit the influence in terms of priorities based on how we design it. So we have to be very careful as we design algorithms by how much they are being influenced by what we put into it and how we train it. We'll talk more about that in the future. But humans definitely have different priorities, conflicting goals, that can limit our decisions. So if we just go back, we can't process all the information. We tend to go with sufficing, whatever's good enough. We suffer from bias. So let's just take a moment and go through some different types of bias that impact humans. And then as we look at machines and algorithms solving the problems, we want to be cognizant of the fact, can we make sure these biases are not injected into the system so that we can make better decisions. So I'm just going to pull up a Word document here so that we can define some of these biases. So let's start with the overconfidence bias. I'll just make a little bit more space here. All right, so overconfidence is when you think you know more than you do. So we as humans tend to think that we know lots of stuff, and so we make recommendations, we solve problems based on the fact that we think we know it all. We think we have all the information, and often we don't have all the information, and so the recommendations, the decisions we make aren't necessarily the optimal ones if we did have all the information. We suffer from the bandwagon effect, which is we think things because others do. So when you think about Academy Awards, do you watch those movies simply because they've been nominated? So we're under the assumption that those people must know something, and so we just jump on the bandwagon. Okay. The next one here is confirmation bias. And confirmation bias is where we focus on info that supports our theory. Okay. So we're looking for confirmation. We are looking for those who agree with us, who give us data that supports our views. So if we think about, do you only listen to liberal news radio or conservative news radio? You want the opinions and perspectives and facts that support the side that you're already on. Focusing bias is where we place too much importance on one area and lose the big picture. So let's say, for example, that you have been waiting hours for your Taylor Swift tickets and you you don't get them. They're sold out. If you waited 5 hours, if you waited 2 hours, does that change how upset you are? Well, mostly we would say, oh, well, if I waited 5 hours, I'd be way more upset than if I waited 2 hours and didn't get them. But is that really true? Your level of disappointment in getting the Taylor Swift tickets is probably the same level of angry. But what we do is we tend to focus and place too much importance on one particular piece of information, the amount of time. And we see that when we are dealing with people providing us information. So people are providing you details about a concern they have or something that happened. We might focus all of our attention on one bit of information and kind of attach ourselves to that one little piece of information and put more emphasis or less emphasis on what they're saying based on that, losing sight of the bigger picture and not realizing how much our perspective and our recommendations are being skewed simply by the information that's being given to us and our focus on one particular detail. Tied to that is framing bias. Framing bias is where we draw different conclusions based on how the information is presented. So remember, when you're making decisions based on information people collect and give you, how they frame it, the story they tell, is going to impact what you do with it. And so it might be that they add a bunch of details that make you feel, okay, well, this is really important, or they might provide, like we're talking about the Taylor Swift. If I tell you about how, I spent all week preparing to get those tickets, then I took a day off work so I could sit online and try to be one of those tickets. I'd save money for that particular event. Right? How I frame the story changes the priority that you give to what I'm saying. If I just framed it in terms of, oh, yeah, well, I didn't get the tickets, that changes, right, how people feel. And so how things are framed, how the story's being told, how much detail there is, what perspective it's being told from can all influence the decisions and recommendations that you make. All right, let's look at observational selection bias. Observational selection bias is when we see things we haven't seen before, then they must be, we see things that we haven't seen before, so they must be happening more often. So if you hear more now about plane crashes and issues with planes, there must be a bigger problem now with planes than there has been in the past. We hear more about child abductions now than we have in the past. Are they more frequent? Is this a bigger problem than they used to be? Well, not necessarily. Perhaps it's now that we have international news, 24-hour news. We get Amber Alerts for children in provinces, multiple provinces away. Because information is more greatly shared in Reddit and online, we just have access to more information than we had. It doesn't mean that the prevalence, the number of times that planes have problems or that children are abducted, is any different. But because we're hearing it more, we tend to think it's a bigger issue. So you can start to see how focusing bias, framing bias, observational selection bias, they all kind of feed off of each other, and they're all influencing the decisions you make, but they're not grounded in actual facts, right? And so one of the reasons that we would use AI or machine learning to help us identify issues, make recommendations to solve issues, is that the technology would be less inclined to place more importance on one area than the other, or be swayed by how things are worded or the details that are provided, or even to assume that things are more frequent simply because they happen more often. But it does really come down to how we train the algorithms, which is why you're taking this training in data analytics, because we still need humans in the loop, even if we're using machines to help reduce some of these biases. Here's the one I suffer from the most. This is planning fallacy. And the planning fallacy is that things will take less time or effort than you think they are. So, you know, oh, that project is only going to take a couple hours, no problem. If it actually takes longer, more effort than you had planned, then we are being influenced as well, right? We have this unrealistic expectation that impacts what we choose to do and how many activities we get involved in, because we all think, there's no problem. It doesn't take too much time. I'll get it done. There's a couple more we want to go through, so let's just crank through them here. We have sunk cost error. This is where current choices can't correct for the past. I like to think of in The Lion King, where the baboon slaps the lion aside the head, and the lion says, "What'd you do that for?" And he says, "It doesn't matter, it's in the past." And he says, "But it hurts." Well, sunk cost error is where we put a bunch of money into a project. It turns out it wasn't a good idea. And we then, because we feel obligated, because we put all this money into the project, we keep putting more money in. So we're chasing good money after bad. And that sunk cost error is where we keep putting more money in just because we have all the money tied up and sunk in the past. So the thing with the sunk cost error is that our current choices, they can't correct for mistakes we made in the past. We need to just kind of ignore them and move on, chalk it up for we learned. That money's gone, but we shouldn't be wasting even more. Tied to that is the escalation of commitment. An escalation of commitment is where you refuse to admit that the past decision was wrong. And so to save face, right, because you refuse to admit that you screwed up, you just keep going. So while sunk cost is money, escalation of commitment, we're talking about time. We realize that it was a wrong decision, but in order to protect ourselves and not admit that we're wrong, we just keep going at it. And so these mistakes are very human mistakes: sunk cost error, escalation of commitment, where we just are so tied to what happened in the past, or the fear of looking like an idiot, or that we didn't do the right thing, that we just keep going the wrong direction regardless. A couple more here. Self-serving bias. This is credit for success. So we take credit for success. Blame others if it goes wrong. So if it worked out, it's all me. I will claim that it was a brilliant idea. But if it doesn't work out, it wasn't me. I was just doing what I was told. So-and-so screwed it up. I built it, but, they messed it up when it was being implemented. So it must have been somebody else's fault. 3 more here. Hindsight bias. Hindsight bias, right? That's the 2020, where we all think that we would have accurately predicted outcome, right? If you asked me that Apple was going to be worth so much money back in the 80s, I would have told you it was an investment worth doing, right? Hindsight is 2020. Knowing what we know now, we would have done better. So here we're taking credit, right? We're saying, we would have totally predicted what was going to happen. Last 2 here, anchoring effect. This is where we make decisions without information. So we look for an anchor. Suppose you're trying to predict what's going to be happening to demand for your product, whatever you're making, and it's a new product, you don't have it out yet, so you're looking for information when you don't really have any. So we're looking for anything that can serve as an anchor, whether or not it is actual relevant information that would actually help us. So for example, if we're just a general one, if you're trying to think of what's more common, words that end in ing or words that end in N, right? It's really going to come down to what you can, let's not do that. It's the next example. Confuse you by mixing up examples. That's good. All right, anchoring effect. We're making decisions without information, so we're looking for an anchor. We don't have the information, we're looking for things that might be clues. We have to be very cognizant that we might be perceiving something as informed and a clue when it really isn't. So if I asked you, for example, how many different programs does Red Deer Polytechnic have, and I provided you options. I provide you with more than 15, less than 15. And then I asked you to guess how many actually were there. Well, the fact that I offered you this more than 15, less than 15 is actually going to mean that when you actually guess, you're probably going to guess a number that's on the lower side, 8, 20. If I'd given you the same question, but given you the options of more than 30, less than 30, and then asked you to name the exact number, you'd probably give me in the range of 25 to 40. Now, those choices that I've given you above or below, I randomly put a number in of 15 or 30. They're not grounded in fact. But because you have no information, you're trying to hang your hat on something. And so you're looking for an anchor, something to help inform you when it's not there. And you need to be cognizant of the fact that what you might be anchoring yourself to might not actually be relevant. The last one, the one I was just trying to give you an example for that I switched gears on, is when we focus on options we can relate to. We can think of examples of. So in terms of management and in terms of work, if a customer comes to us or an employee comes to us and tells us a story about an incident, if it's something that we can relate to, then we're more likely to side with them and champion them. If it's something that, this is the first example we've heard, it's not something we've experienced personally, we're less likely to champion them or try to resolve the issue. And it's simply focusing on things that we can relate to. And we need to recognize that we have a tendency to do that. We have a tendency to go with the solutions that make the most sense to us, the ones where we can think of examples of. So if I asked you, what is more likely in a book? Words that end in ing or words that end in n, right? You might answer differently depending on what you can think of. More words that end in n, in, an, all those little words. Or maybe you think of more active words like reading, writing, thinking, all ending in ing. Whichever one you can likely think of more examples of is probably the one that you chose in the question. And it's not because it's grounded in any type of facts, but simply because you can relate to it, because you can think of examples to it. So we've been going through all these different types of cognitive bias to recognize that humans are highly influenced by lots of things, okay? Our own personal self-interest, our need to save face, our own inability to recognize time, the influence of others, the way people frame things, the lack of information means we search out for information that doesn't exist. All of this influences us, which brings us back to the discussion about bounded rational and the fact that humans can't process all the information and humans suffer from bias. And so because of all of these, we have artificial intelligence in our decision-making process. We can use artificial intelligence and machines to help support our decisions. So we're going to use predictive, diagnostic, descriptive analytics to help make more accurate decisions. So the machine's going to help analyze the data. We're going to make the decision. Or we can have decision augmentation. So we're using predictive and prescriptive analytics to help recommend solutions. We know that here's what could happen, here's what we should do, here's our options. So we're using AI to help narrow down the options and we choose from there. Or we can have decision automation. We use our prescriptive and our predictive analytics to automate the decision-making process. We use cognitive analytics to understand the information, the past, explain what could happen, identify what we should happen, and then make it happen. So the role of AI in decision making can be to support decisions, augment decisions, automate decisions. In all these cases, when we're making decisions, we're analyzing data. And so we come back to, are we doing descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics? So we'll just end this video here with some examples of roles of AI in decision making. So Amazon has recommendation engines, which identify which products you should buy and you should like based on what other people buy and like. Tesla has self-driving vehicles, uses image recognition to identify this is a stop sign, so we should stop. We use classification algorithms to find cancer. We can identify high-value customers based on their behaviors. We can shortlist applicants' resumes by identifying different themes, different sentiment, and what is a good applicant and a poor applicant. We can monitor performance. We can track the performance of our organization with dashboards. We can create bots to help with customer service. All of these are artificial intelligence combined with data analytics. And so we're going to be looking at a number of these and how do you create these models as we look at additional videos. So we have descriptive, diagnostic, predictive, prescriptive, and cognitive analytics, increasing in complexity and increasing in value added for the organization. So in our subsequent videos, we're going to be using these tools, figuring out when to use each one, how to do it, and what it's telling us. And so ultimately then the decision becomes, are you using these tools to make decisions, to have the AI help you shorten up your options, right? Shortlisting, so I can then choose just from a couple people instead of all the applicants, or are we automating the process entirely?